Is a mathematical way to figure out where to put the decimals when you're multiplying decimals times decimals. So I could actually multiply this all out and use the way that the math people teach. But an important way, because when people miss these, they usually miss them by putting the decimal point in the wrong place. They usually miss them by putting the decimal point in the wrong place. So we're going to look, I've given you the numbers that are in the product. I've given you the factors, and I've given you the numbers that are put in the product. Your only task here is put the decimal points where they belong. And we're going to use estimation to do that. So I'm going to use what they call front-end estimation. I'm just going to look at the whole numbers. And if I have just the whole numbers, now think this, just the whole numbers, and I go 2 times 1, what is 2 times 1? 2. 2. So my answer needs to be somewhere around 2 wholes. My answer needs to be somewhere around 2 wholes. Well, if I put it here, it's way less than 2 wholes. It's less than a half, actually. If I put it here, I'm going to have 2 wholes. Okay? The next one. I have 63 times 5. Well, what is 60 times 5?
300.
300. So my answer needs to be somewhere around 300. So I would put my answer there. Let's look at this one. Just front-end estimation, 5 times 4 is? 20. My answer needs to be somewhere near 20. Okay, listen to this one. I'm multiplying 34, but I'm multiplying it by less than 1. If I multiply by by 1, it stays the same. If I multiply by a number bigger than 1, it gets bigger. If I multiply a number by a number that's less than 1, it's going to get smaller. So my answer is actually going to be smaller than 34. Near 34, but smaller than 34. So it's going to go there. Now let's look at the way that you're taught to figure out where the decimal point goes. What we do is we look. How many numbers are behind the decimal point in 2 and 2300ths? 2. How many numbers are behind the decimal point in 1 and 2/10? 1. If I add those together, I get 3. There needs to be 3 numbers behind the decimal point. Estimating it helps you put the decimal point in the wrong place. If I only put 2, I'm going to get 26 and 7600ths. But if I estimate first, I'm going to know that I'm a knucklehead if I put my decimal point here. Don't be a knucklehead. How many numbers are behind the decimal point in 63 and 7/10? 1. How many are behind the decimal point in 5 and 4/10? 1. There have to be 2 behind it in the product. How many behind it here? 2. How many behind it here?
1.
How many behind it in my product? 3. How many behind it here?
1.
And here? 2. 3 behind it in my product. Notice that I also didn't line the decimal points up when I multiplied. When I multiply and there are decimals in it, the way that I do, people say just ignore them and multiply like normal. But what I would do is I would take and I would make this 637 times 54, and I still know how many need to be behind the decimal point. Then I could multiply 4 times 7 is 28, 8, 2, 4, 12, 30, 14, carry the 1, 4, 24, 25. If I did that right, see I multiplied 637 times 4. And then I'm going to start in the tens place. 5 times 7, 35, 5, 3. 5 times 3 is 15. Plus 3 is 6 is 18. Carry, and 5 times 6 is 30. Plus 31. And then I add, and I get 8. And I get 9. And I get 14. And I get 1, 2, 3, 4. And that's 3. I did something wrong there, right?
Yeah.
This should be 13. And it's 8 times. Oh, because I wasn't supposed to carry there. My bad, I was doing it fast.
Well, I think we can tell.
Okay? I just did it, ignoring the decimal points, and then I can go back either to my estimate, or I can go back up here and count. It is much easier, at least in my mind. Now, there's a lot of weird things in my mind, but it's easier in my mind to rewrite it and solve it without the decimal points. And then put my decimal points in. But it's important to estimate first. You're going to be less likely to put that decimal point in a silly position if you estimate first. I'm just saying. Okay? Don't argue with me. I'm just saying. Please subscribe.